with cargo and equipment that will enable larger crews to reside aboard the complex. This 27th mission to ISS, also known as Utilization Logistics Flight 2, will include 4 spacewalks to maintain critical parts of the station's solar arrays and relocate hardware and equipment outside the station in preparation for future shuttle missions. The crew of Endeavour is a mix of experienced astronauts and first-time space travelers. Navy Captain Chris Ferguson will serve as Endeavour's commander. Ferguson, who last flew as the pilot of STS-126, will be making his second trip aboard the shuttle. This will be his first flight as commander.
Every commander would like to think that he's got the best crew that was ever assembled to fly a space shuttle mission. But I'm no exception. These folks are extremely talented, very hard-working.
Air Force Colonel Eric Bowe will make his first voyage into space as the pilot of Endeavour. Bowe will assist with rendezvous and docking activities and will also fly the shuttle as it undocks and flies a 360-degree loop around the station at the end of the mission. Veteran space flyer Don Pettit will serve as Mission Specialist 1. Pettit first flew as a crew member of Expedition 6, spending 5.5 months aboard the space station. Navy Captain Steve Bowen will be making his first journey into space aboard Endeavour as Mission Specialist 2. Bowen is the first submarine officer selected by NASA as a mission specialist. Navy Captain Heidi Stephanishin Piper will also be making her second trip into space, serving as Mission Specialist 3. In 2006, Piper flew on STS-126 with STS-126 Commander Chris Ferguson. She will be the lead spacewalker on 3 of the mission's 4 planned spacewalks. Also making his first spaceflight is Army Lieutenant Colonel Shane Kimbrough. Kimbrough, who spent 4 years as a flight simulation engineer on the shuttle training aircraft before becoming an astronaut, will serve as Mission Specialist 4. Dr. Sandy Magnus will accompany the STS-126 crew to the station. Dr. Magnus will remain on the station and serve as flight engineer and NASA science officer on Expedition 18 after Endeavour departs. Endeavour will bring home astronaut Greg Shamatoff, who has served as flight engineer on the Expedition 17 and 18 crews. Shamatoff has been a resident on the station since arriving on STS-124 in June. Since the shuttle's return to flight in 2006, the International Space Station has grown dramatically, both in terms of overall size and interior volume. With the recent delivery of the European Space Agency's Columbus Laboratory Module and the Japanese Kibo Laboratory Complex, the space station has room to accommodate 3 additional full-time residents within the next year. Although the new modules have been installed on the station, they are not quite ready for occupancy.
What I think a lot of people don't completely understand is that when we launch these heavy modules, we launch them essentially empty. I mean, they're shells. They have the infrastructure, they have the wiring and the plumbing and the piping, but as far as actual useful internal components, there are none. They're launched empty.
It's a bit like when a house is built. A framing crew will come, and in 10 days, the basic layout of the house is done. From somebody looking street side, it looks like it's finished, but it'll take another 2 months for the plumbers and the electrician and the sheetrockers and the cabinet makers to outfit the house with all the finished carpentry.
We're basically taking it from a 1-bathroom, 3-bedroom type of house and increasing the size to like 5 bedrooms, 2-bathroom type house.
The dramatic transformation and remodeling of the interior of the space station will begin to take place over the 7 days that the shuttle is docked to the station. Endeavour's largest payload is the Leonardo Multipurpose Logistics Module, an orbital moving van that is carried in the shuttle's payload bay and attached to the space station on Flight Day 4, the day after Endeavour docks with the ISS. Leonardo will hold approximately 12 metric tons, or 27,000 pounds, of cargo, including food, clothing, and supplies, a second treadmill and space galley, a second space toilet, and 3 new sleep stations for the soon-to-be expanded crew. The logistics module will also contain new regenerative life support components that will be installed on the station. This system will collect and process wastewater, condensation, and urine that would normally be jettisoned into space.
The concept may sound, to some people may think it's downright disgusting, but if it's done correctly, you process water that's purer than what you drink here on Earth.
The installation and use of the Regenerative Environment Control and Life Support System will enable scientists to demonstrate the capability for recycling that will be necessary for future missions to the Moon and Mars. The STS-126 mission includes 4 spacewalks beginning on Flight Day 5. During the first spacewalk, Piper and Bowen will remove an empty nitrogen tank from the outside of the space station and place it in the shuttle's payload bay for a return to Earth. The spacewalking astronauts will then turn their attention to servicing the station's starboard solar alpha rotary joint, the mechanism that allows the station's solar arrays to pivot to track the sun. The rotary joint has operated in a limited fashion since high electrical currents were detected a year ago due to the partial loss of lubrication along the joint's rotational ring.
The solar alpha rotary joint, or we just call it the SARG, there's basically 2 axes that we can rotate the arrays, and if you can imagine the space station out in front of me, we have the rotary joints on the edge. As the space station goes around the Earth, obviously these are solar arrays, so they need to point at the sun. Well, the solar alpha rotary joint, the SARG, actually allows us to basically pitch the arrays in this axis. So what we're going to do is basically go in there and clean and lubricate that area to help that rotate.
2 days later, astronauts Piper and Kimbrough will venture outside for the mission's second spacewalk. Their first task will be to relocate 2 small platforms, also known as CETA carts, that are used to move astronauts along the rail system attached to the station's truss.
Every now and then we have to move the CETA carts to different sides of the space station just so that the mobile transporter can move down the rails based on whatever mission is there. So we're actually moving them in preparation for 119, which is the mission after us.
Later, during the second spacewalk, Piper will continue to clean and lubricate the starboard solar rotary joint and will press ahead with the installation of new trundle bearings. Kimbrough will spend some time cleaning and lubricating the hand at the end of the space station robotic arm, known as the latching end effector, that has exhibited stickiness when it is used to grapple objects. The third and fourth spacewalks will be almost exclusively focused on the completion of the lubrication of the starboard solar alpha rotary joint.
You know, the people at the Kennedy Space Center, they work on the space shuttles day in and day out. And periodically, I've asked people who I've just met, do you ever forget the fact that you have an extremely special job? And by and large, every one of them, they don't even pause a moment. They say, no, that fact is never lost to me. So I'd like to think that we do have this relationship with the people who maintain and construct and build the space shuttles and the International Space Station. We have a great relationship with them.
The trainers we have, the people in mission control, I mean, everybody is top-notch and just wonderful to work with. And there's never really a bad day here because of the people that are around you all the time.
I just can't say enough to express my gratitude to the folks for the outstanding job that they do, because they all feel so passionate about what they're doing.
It's amazing. You know, it's funny because Hollywood makes it look so easy to jump into something and to fly into space, but if anybody ever took the time to sit out there and think, what would it take to do that? If I were to start today, how would I get something to safely take me into orbit and bring me back? I think they would quickly be quite amazed at the accomplishments that NASA has had so far and will continue to have in the future, and the number of people it takes to do that, and the incredible dedication. I tell people that, you know, this is just an amazing group of people here to work with on all sides.